Let's go. I'm recording this for the homies online. And so you can reference back if you have a question. So, story, problem, day, context, real life, data modeling. Let's just jump right into it. Harmonic oscillators, oscillating harmonicas, yo-yos. We're going to talk about everything that matters here. So, another water problem. Do you guys remember seeing this from that quiz we took a while ago? So, water, tides goes up and down, right? Because of the moon. Flat earthers would disagree, but they are wrong. So we have a seawall that's measuring the depth of water. It goes from 5 feet at low tide to 11 feet high. We know low tide happens at 6 and high tide at noon. So let's make an equation for it. So they're going to start us off with this one. They're going to give us the graph and we make the equation. Later, it's going to be, this is the story, you make the equation. So what I would suggest is you start with like sketching a graph. You know what I mean? Because if I gave you a graph, we've gotten really good at making the equation for it. This one, they gave us the graph. Let's find our letters. How do I find D? D is my midline. So that's going to be 8. Okay. Oh, good. There's no phase shift on this, right? So I need to find C. How do I find A? Amplitude, which is 3, right? All right, I'm almost there, right? How do I find my B? What's my period? I go from here to 12, right? So if my period's 12, how can I find B? Yeah. Ooh. If you need to cross multiply, which is fine, you get 12b equals 2 pi. So B would be 2 pi over 12, right? Which is also known as pi over 6. Like I had to cross multiply, divide. I did that one really quick. Do you guys have any questions on it? We've been doing a lot. So I have my B, so it's gonna be pi over 6 t. So far, not too scary. Let me check myself, make sure I did it right. I did. That's one cookie for me. All right, we good? Now here's, oh man, I'm gonna have to zoom out. So based on my model, when is the tide rising? All right, so let's use our picture graph, right? From 0 to 12 is my period, right? So that means where's my min gonna be? At 6 comma 5, right? Do you all agree on that? So when am I rising? So from 6 to 12. Now we want, there's more than one answer, right? When am I going to rise again? 18 to 24, right? Now what kind of sand, well, I guess I shouldn't say that because that's military time. Let's use real life time. So from 6 a.m. to 12 p.m., right? Or noon, as my homies call it. And what's my other time every day? What's 18 and like, yeah, 6 to... Wow. Does that make sense? My period's 12 hours, right? So if it happens here, it'll happen again 12 hours later. That's actually kind of how tide works. That's why this is a fishing lesson. One's fishing the best in the morning and at night, because when tide comes in, it brings up the detritus from the ground and the small fish feed. And when small fish feed, big fish feed. Dead stuff. If you'd like to learn more, subscribe. Yeah, hit the like button. Hit the bell. Don't miss our videos. Hit that bell notification. All right, a yo-yo. You guys know yo-yo? So yo-yo goes down and it goes up. Do you agree on that? I'm going to take all the fun out of every child's toy that's ever existed. Let's start by a yo-yo. So did you know that you can model a yo-yo with this equation, with its motion, its position over time, right? Where is it going to be at above the ground if you're constantly yo-yoing? So that's my equation. So when does the yo-yo return to its maximum height for the first time? So this is my equation, right? Now I got to think about this. I'm going to drop the yo-yo. It's cosine. So I'm just going to draw a quick sketch. So I'm going to start here and then go like this, right? Because it starts from my hand, it goes down, and it comes back up to my hand. Now when does it return to maximum height? So at time 0, we start at max height. What's my, when's it going to come back to max height? Whatever the period is, right? And what is my period of this function? What's 2 pi divided by pi is 2. So t is time in seconds, right? So at 2 seconds. All right, so what is the max and min heights? What's my amplitude? 1.5, right? What's my midline? So again, you don't have to draw the whole graph, but I'm going to sketch a graph just to kind of see what's going on, right? So I'm moving my point up to my midline up to 2.25, right? And then from 2.25, I go up 1.5. I'm going to go down and come back up. I'm going to go down 1.5. Does that kind of make sense what I'm doing here? I'm drawing a sketch so I kind of see what's going on. I think someone else said it. You take your amplitude and you add it to 2.25 and subtract 2.25 from it, right? Or subtract it from 2.25. But I'm drawing a sketch just to help me like visualize what's going on. So what is the maximum height then? It would be 1.5 plus 2.25, right? So my maximum is 3.75 feet, right? And the minimum then would be 2.25 minus 1.5. So it'd be 0.75 feet. You know what I'm saying? Now, some of you might be asking, can I always take the amplitude and add it to my shift? Mm-hmm. That'll always be your max, right? Could I always take my amplitude going down and add it to my midline? Yes, that will always work for your max and min. But I like that drawing to help me visualize why. All right, so we've learned about yo-yos. We've learned about water. What else you guys want to learn about? You guys know how to take a nap. You already know that. What's something y'all don't? No. Is he okay?
Tough crowd.
Tough crowd today. You guys all have a harmonic oscillator, right?
I like harmonicas.
How about this? No, I absolutely hate it. Do you guys know how a piston works in a car? And it's on a, oh shit. Is that a harmonic oscillator that goes up and down the same distance every time? Combustion engines are harmonic oscillators. Okay? We can model their movement by either one of these equations depending on where we're starting, right? Cosine, you start up. Sine, you start in the middle. Yeah, they don't have a shift in there. Now, a big part is the maximum displacement of the object. Okay, so the period is 2 pi over max displacement. Which makes sense. You guys don't know. But frequency, isn't this the same thing? We're just calling W is B, right? That's what I want you to realize. They're going to use this equation. That W is just a B, right? So if you want frequency, it's B over 2 pi. But that's your maximum displacement over 2 pi. That's how many oscillations per unit of time. So like, if you want to know how much your pistons are firing in an engine, that's actually your frequency of a harmonic oscillator. Yeah. Engineering is fun. I told you guys this is real life stuff. Let's talk about a different harmonic oscillator. It's almost like a harmonica, but it's a tuning fork. Has anyone ever hit a tuning fork and you listen to it? It's shaking. Yeah, that's physics. Sound is harmonic oscillations, actually, right? It's releasing waves, ripples through space and time. So we can model a tuning fork by this equation. But now I want to know what is my displacement. So AKA, I guess it's asking what's B. So my frequency is 386. What's my equation for frequency? It's B over 2 pi, right? But for this equation, what's my B? That W thing, right? You know what I'm saying? Like, these are the same equation, different letters. So if that's my frequency, I set that equal to my frequency. Yeah, of course it is. What else would it be? It's like if Disney wrote a 3. It was a 2. I added it. What do I do to get that W by itself? Times by 2 pi. Times by 2 pi. And I get W equals 772 pi. I guess I could have done that. Yeah, I probably could have. Why am I using pi in my answer? Because I like pi better than the answer. No rounding, right? Now, what's my label? Oh, you guys don't. Oh, answer. Oh. It's radians per second. How are you supposed to know that? Oh, now you do.
Oh, yeah.
All right. Let's do more harmonic oscillation. Oh, we're doing great. Let's say I have a ball and a string. And it's going to go boing, boing, boing. Like cartoons. So I have a ball and a spring. And I'm going to pull it down 6 inches below its rest. And release it. Now, if there's no friction and we're in a vacuum and I have a spring, it's going to go forever, right? Once I start it? Yes. In space, if I'm in space and there's no gravity or friction, if I release this 6 inches down, it's going to hit this and the force is going to bring it 6 inches up. That's inertia, right? It's inertia. It's going to be equivalent. It's going to go 6 inches up, and then it's going to go. Yeah, that's how it. In a perfect system, that's how physics work. The period for the motion is 4 seconds. What's the equation? Where are we starting? Where are we starting? We're starting below, so we're going to start 6 inches below. So let's think about this as a graph for a second. It's how I would do it. We're going to start at -6, and we're going to release it. And what's it going to do? It's going to go up to 6, and then what's it going to do when it hits that? Drop back down, right? It's going to do that forever. I don't need a dot line there. Does that make, you don't need to draw a graph. I'm just drawing this for my own, like, I like to see what's going on. So if I need to graph this, would I use sine or cosine? Oh wait, it asked me. Oh no, am I going to use sine or cosine? I'm going to use cosine because I'm not starting in the middle. I'm starting with it pulled down. Ooh. Now, am I starting at a max or a min? Min, so I got to do a negative, right? What's my amplitude? So it's going to be -6 cosine. No shifts, right? Because I'm making this equation. I'm going to make it with no shifts. What's my, the period is 4 seconds. So how am I going to find my b? 2 pi over b equals 4, right? So 2 pi equals 4b. So 2 pi over 4 is b, right? Can't reduce it. Too bad. I'm going to do it. I don't care what you say, person. So I do pi over 2 t. Isn't it amazing? Now, at any given time, I can tell you exactly where the ball is. No, because I made the equation. I am the captain. So if I'm writing an equation from scratch, I'm definitely not going to make it. So there's a shift. There's no resistance. Resistance is futile. What?
They're thinking too hard about the cross.
These are theoreticals.
All right.
All right.
So this is real world.
No, this is real world. If you were in space, it would work.
So that's like.
I said there's no friction. There's no compressive forces.
He's making it space.
All right. So we have a mass oscillating up and down from the bottom of a spring. So we're going to put a mass down here, and we're going to put it on a spring again, right? And it's going like boingy, boingy, boingy with no friction or air resistance, and there's perfect elasticity. Real life situation. If any of you guys are going to be taking physics soon, I'm not going to lie, this right here, you're learning a lot of physics, actually. Well, now you did it again. So now it will be a perfect harmonic oscillator. Now, I will say this. If you take higher level math, your equations, you're actually going to graph them, and they're going to look like this. And you're going to learn how to graph those, because that's how the motion's actually going to be, right? It's a trig function with to a trig function power. Does that make sense? Because it oscillates. Because actually, they found even heart, like AFib. Do you know how your heartbeat starts slower and then it gets really fast until you flatline? That's a trig function, actually, because it's an oscillation. But no, if you go further in mathematics, you will, like Calc 2, you deal with that stuff a lot, because then it's real life. We're going to assume not real life, and then it'll get real life if you go further. So we're going to wait. If the weight is displaced by a maximum of 4 centimeters, it takes 3 seconds for one cycle, and we're going to start at rest this time. Okay? So if we are starting at rest, where are we starting at? 0, 0, right? We're going to start at 0, 0 now. So it's already going. We're just going to model it. And if I want to model something, it's going to be easier just to start at the origin, right? Because it's periodic. So if I'm starting at 0, 0, which trig function am I going to use? Sine. Now this time I'm not going to graph it. I'm going to look at it and use that information. Displacement is 4 centimeters. It means it moves 4 up and down, right? So what's my amplitude? 4. Could I do -4 or +4? It doesn't matter, right? I'm modeling this thing that's going to go on forever. It could go down or it could go. It doesn't matter. It's going to work. 30 Find it takes 3 seconds for one cycle. What's that mean? That means 2 pi over b equals 3. Let's see if we got it now. It's going to be 3. It's going to be 2 pi over 3 equals b, right? Why have I taught, guys, do you remember geometry? What can you do with ratios when you set them equal to each other? You can swap your tops and your bottoms across. Yeah, that's a rule. Remember we did in trig. When we do trig, when x is on the bottom, you swap your sign and your x. But anyway, that's a shortcut. You can do it with any rate. If you have, guys, if you have like 2 over x equals 1,000, you can, that a rule is you can just do this. That's an actual rule of proportions. We did in geometry. I guarantee I can show you in the notes. I can show you in the video where I do it. You do it with trig because when x is on the bottom. Anyway, that's my b. I'm a b. I'm a b. I'm a b. That's it. Doesn't matter. It won't matter because it's not rest. It's already going. You know what I'm saying? So we get to make up. Yeah, it's already oscillating. So it doesn't matter which way we go. You're saying you're assuming starting at the origin. Yeah, they should probably tell you where you're going to start going, though. If you're doing a real-life engineering, you better know because doesn't matter. All right, guys, I'm going to do example 6. I'm going to finish this whole one because I'm on a roll and I'm feeling good about this. Be honest, is this looking worse or not as bad as what you thought? You're looking for a period and amplitude, right? Do you say you need a different teacher? Oh.
That could be a compliment.
Every day I just show up and I just think it's going to be better. All right. Dang it, I'll zoom out because I want to keep this all on there. All right. Hey, have we done a Ferris wheel problem? And now we're going to do it with a shift. Get the shift. Get that shift. No. Ferris wheels terrify me. I don't like being behind open. And my youngest daughter likes to rock it. All right, let's do it. All right, so what I like to do is I'm going to draw a Ferris wheel. It's going to help me think about this. I'm going to label it too. It takes 8 minutes to go. That's crisp. 8 minutes to go around. What else do I know? It's 125 feet above the ground, and the lowest point is 5 feet up. So that's 5 feet. Diameter is 120. Wait, hold on. Its highest point's 125. It's 120 feet diameter. It tells us that in the dealio. And is that everything I need to know? That's everything I need to know. So I would graph it first. What's my midline going to be? What's my midline going to be on this? What's this whole... Oop, 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 oop. How much am I oscillating? What's my amplitude going to be? 60, right? Oh, yeah, it's going to be 60. And 60. No, hold on. Because I'm not going to go down, like, I'm not using the extra 5. The extra 5 is just shifting me up, right? Think about this. Is the circle changing diameter with that 5 or without it? So my amplitude's not going to change with it. Like how much I'm oscillating is not going to change. What's that 5 doing to... So if I'm starting at 0, my midline would be at 60, right? What's that 5 doing to my 60? It's just moving up 5, right? My amplitude is 60. That 5 is going to move it up 5. Let's put it a different way. Amplitude would be my diameter how did I used to do amplitude? It would be my highest minus lowest, like my amp was my highest point minus my lowest point divided by 2, right? So it's 60.
Yeah.
That's another way to do it without the picture. I mean, it's your highest point minus your lowest divided by 2. So now I know that. Where am I going to start on the Ferris wheel? Am I going to start at the highest point, the midline, or a minimum? Min. Now, what's the min on this? 5, right? So I'm going to go to 5. Right? I'm going to get on the Ferris wheel. Doop, doop, doop. That's the sound I make when I walk. And then how long is it going to take me to get back to the bottom? So at 8 minutes, I will be back at 5. Okay. So that means at 4 minutes, where am I going to be? I'm going to be white knuckling it, scared as all can be at 125. Right? Where am I going to be at 2 minutes? Midline, right? Cut in half, cut in half. Where am I going to be at 6 minutes? Midline. They always do look like triangles, kind of. All right. Jack Skellington? The mayor? Never mind. Mayor? So what's my amplitude? What's A? 60. What's B going to be? Ooh, let's use our new trick now. It's 2 pi over B equals 8. So what's it going to be? 2 pi over 8. Or, think how much time you all wasted on your homework. What's my C going to be? Nothing, I didn't shift it. What's my D going to be? 65. Is that everything I need in the world? And a warm blanket, of course. I'm not a blanket guy, actually. I don't like using blankets. So I'm going to do 60. Oh, wait. Negative 60? Yeah, because I'm starting low. If you parachute onto it, that'd be incredible. Like if you start up at 125 feet. All right. No. Oh, underground Ferris wheel? That seems pointless. I don't know. Do we agree on that?
No. Yes, actually. It's the same.
All right, what's the last question asking?
What time is the rider?
Oh. When am I 65 feet above the ground? Hey, if this is on the AP test and you thought the midline was 60 and you get to this question where it wants you to know 65 feet without a calculator, you did your midline wrong. Does that make sense?
Yeah.
What's up, Reese? Because that's where our midline is. Our midline without the shift would have been 60. Because, no, think about the circle. It's 60. In the circle, we're going to oscillate 60, right? So if we start at 0, we would have started at 0, 0, and went up, and my midline would have been 60. But that 5 shifted everything up 5. So that's why it's 65. Because the midline's 65. Do you guys agree this is 2 seconds and 6 seconds? Because it's where it crosses our midline. And again, if you didn't have 65 as any part of this and you get to a question asking about something being 65, go back. Go back and check it. 65 was important. Because if it's a non-calculator, these have to be things that you can answer just by looking at the graph.
Or 2 minutes. Check.
Oh, I put seconds. That would be whee! That'd be a crazy Ferris wheel. The Death Drop or whatever they call them. Those things terrify me.